The mystery of what existed before the Big Bang has perplexed scientists for decades. As the field of cosmology advances, some possible answers are beginning to emerge, and they are as unsettling as they are fascinating. Renowned physicist Brian D. Cox has provided new insights into this enigma, offering a perspective that challenges our understanding of the universe. According to Cox, what existed before the Big Bang was not a state of absolute nothingness, but rather something strange and terrifying, a concept that pushes the boundaries of our current knowledge of the cosmos. The question of whether the universe came from nothing or whether something predated it remains a topic of intrigue. While we do not have all the answers, many physicists continue to search for an explanation. From my perspective, the idea that something can come from nothing seems implausible. For something to exist, there must be some form of material or components in place. But for those components to be available, something must have existed first. So where did the material that triggered the Big Bang originate? What occurred in the first moments to create that material? Peter O., a physicist from Australia, presents a compelling thought. He suggests that the last star in the universe will gradually cool and fade, leaving behind a void of light and life, creating an endless dark epoch. As black holes eventually consume all matter and evaporate into the faintest light, space will stretch outward to a point where even this light will dissipate. This marks the beginning of a chilling yet fascinating end. However, some cosmologists propose that the universe we inhabit might have originated from a cold, dark, and empty universe, similar to the one awaiting us in the far future. Before diving into this idea, let's first explore how physical matter emerged. To trace the origins of stable matter, including atoms and molecules, we must recognize that none of this existed immediately following the Big Bang, or for several 100,000 years after it. We have a good understanding of how the first atoms formed as the universe cooled enough for complex matter to stabilize. These atoms later fused into heavier elements within stars. However, this explanation still does not address the crucial question: did something come from nothing? Let us take a step back in time. Around 100,000th of a second after the Big Bang, the first long-lived matter particles, protons and neutrons, which make up atomic nuclei, came into being. Prior to that, no familiar form of material existed. According to physics, we can trace the timeline even further back to processes that took place before stable matter existed. This takes us to the so-called Grand Unified Epoch, a period marked by speculative physics because our experiments have not yet been able to replicate the energy conditions necessary to investigate these early processes. One hypothesis suggests that the universe was initially composed of a soup of fleeting elementary particles, including quarks, the building blocks of protons and neutrons. During this period, matter and antimatter existed in nearly equal amounts. However, when matter and antimatter met, they annihilated each other, turning into energy. This process created a cycle of particle creation and destruction, but where did these particles originate in the first place? Quantum field theory suggests that even a vacuum, which we often consider empty space, is teeming with activity in the form of energy fluctuations. These fluctuations can result in particles that appear and disappear almost instantaneously, which has been observed in countless experiments. Thus, even the vacuum of space is not nothing, but rather an energetic field that fluctuates unpredictably. However, this raises a philosophical question: can something truly emerge from nothing? Some argue that even empty space has some form of activity. Philosopher David Albert has critiqued the idea that something can arise from absolute nothingness. For example, if we consider the origins of space-time itself, we venture back to the Planck epoch, an era so early in the universe's history that our current theories break down. During this epoch, which occurred only a fraction of a second after the Big Bang, space and time themselves were subject to quantum fluctuations. To understand this period, scientists need a unified theory of quantum gravity that merges quantum mechanics and general relativity. While we don't yet have a complete theory of quantum gravity, models like string theory and loop quantum gravity suggest that space and time may be emergent properties, similar to waves on an ocean. These models propose that what we perceive as space and time are products of deeper quantum-level processes. What is clear is that physics has never confirmed the existence of something arising from absolute nothingness. During the Planck epoch, our conventional understanding of space, time, and causality breaks down, yet all current theories of quantum gravity involve physical phenomena, quantum precursors to space and time. But where did those come from? The Big Bang is typically regarded as the beginning of the universe, a moment when the cosmos was hot, dense, and expanding rapidly. Remnants of this event still exist today in the form of cosmic microwave background radiation, a faint glow, detectable across the sky. However, the question remains, what triggered the Big Bang? As Brian Cox explains, the Big Bang, the event where the universe became hot and dense, represents only one chapter in a much larger cosmic story. What preceded this event might be even more profound, a period known as cosmic inflation. Cosmic. Inflation refers to a phase in the early universe when space expanded at a rate faster than the speed of light. This rapid stretching of space abruptly ended, depositing vast amounts of energy into the universe, which then formed the particles, radiation, and matter we observe today. The theory of inflation suggests even deeper implications. In the model of eternal inflation, the universe is part of an expansive multiverse where inflation never ceases and new bubble universes are constantly being created. This raises profound questions about the nature of existence. Could there be an infinite number of universes, each with its own laws of physics? The idea of eternal inflation leads to the concept of a vast, continually expanding multiverse. This theory suggests that our universe is just one of many, each potentially following different physical laws. If this is true, the origin of our own Big Bang could be part of an endless cycle of creation, expansion, and dissolution of universes. This theory challenges our conventional understanding of emptiness. Space, which we often think of as empty, is actually filled with quantum fields that fluctuate due to quantum mechanics. These fluctuations generate a non-zero background energy, known as zero-point energy, indicating that what we perceive as empty space is in reality teeming with invisible activity. Could the state of the universe before the Big Bang have been a dynamic, energy-filled quantum realm, providing the necessary conditions for a new universe to emerge? Could these fluctuations have triggered another Big Bang? These ideas push the boundaries of our understanding, suggesting that the cosmos is far more vast, intricate, and eternal than we ever imagined. Cox's insights into the universe's origins remind us of the profound and humbling reality of the cosmos. What came before the Big Bang, while still shrouded in mystery, continues to shape the universe we live in. As scientists explore further, they may uncover new answers that could fundamentally change our understanding of existence itself. Through the development of new observational tools, such as the detection of gravitational waves or interactions with dark matter, we may gain deeper insights into the fabric of the universe and the true nature of space-time. The journey to understand. The origins of the cosmos is ongoing, and while there are still many unanswered questions, each discovery brings us closer to unraveling the mystery of what existed before the Big Bang.